All right, cool. So there are still 2 more bits of information that I need to teach you, primarily for the excellence component of this assessment. And that has to do with, again, functional groups. So IR tells us a lot of information of the functional groups, but the mass spec and the CMMR can give us some more information as well. It's a recording, so you can watch it later. Okay. So before I give you the answer to what it's telling us, I need to give you a little bit of background information. So on the top table here, I have put together some examples of isotopes. Do you guys remember what isotopes are? Or should I do a crash course on isotopes? Now, some of you guys might, but some of you guys won't. Okay, we got another piece of paper and talk about it. Actually, I don't even know if I need a piece of paper for it. All right. Do you guys know when we talk about the structure of the atom that inside? No, actually, I'm mindful. Some of you guys have not done chemistry before, so let me do it. All right. So when we talk about the structure of an atom, you have the nucleus. And the nucleus is going to have all the protons and the neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm just drawing carbon. All right? So that is the nucleus. And then what is outside are the electrons. 1, 2, 3, 4, 5, 6. Yes, that's what I want. Okay. So in the center is my nucleus. Inside the nucleus, there are 2 things. What are the 2 things? Protons and neutrons, which are positive, and then neutrons, do they have a charge? Nope. All right. On the outside, we have, electrons. Yes? And they are negative. Okay? When it comes to matter, the protons and the neutrons are far bigger and heavier than the electrons. I believe it's like 1/7,000th of the weight of the protons and the neutrons. So these are basically nil, non-existent, doesn't affect mass. These are what we use to count mass. So atomic number, let me grab another color, keep changing it up. Atomic number is referring to the number of protons and also the number of electrons. So in this example here, I'm just going to start sticking in 1, 2, 3, 4, 5, 6. All right. In this example here, I have 6 protons and 6 electrons. So we got 6, and 6 is the reference for carbon. So when you look at a periodic table, you would see carbon, you would see the number 6, and you'd see the number 12. So just talking about what I'm seeing here. So atomic number is referring to that one. Okay? When we talk about atomic mass, it is that one. And that's protons plus neutrons. Okay? In this example, I have 6 protons, and I also have 1, 2, 3, 4, 5, 6 neutrons. So to be 6 plus 6, that's what's giving me the 12. Oh, clever, clever. All right. Now, atoms do have to have a certain number of protons because that is the unique marker for that element. So if I change the number of protons, I change the element. I can gain or lose electrons. That's fine. The element stays the same. It's now become an ion of that element. So say, for example, sodium, it will lose 1 electron to become the sodium ion, but it's still sodium element, like as an atomic element-wise. Okay? Can't change the proton number. If you change the proton number, you're doing nuclear physics. You're smashing atoms together. Okay? Now, the other thing you can do, the other thing that happens is we can have extra neutrons. Extra neutrons do not change the atomic matter. What that does is it makes an isotope. So isotope is the same element with a different number of neutrons, so a different atomic mass. Okay? Same element, different number of neutrons. Okay? So, when we look at this table up here, what we are talking about are different elements that have isotopes. So carbon right here is normally found as carbon-12. 98.9%, so basically 99% of all carbon is carbon-12. Every so often, we have a carbon molecule with an extra neutron. So it has one extra neutron, so the mass is 13 instead of 12. We call that carbon-13. And it happens about 1% of the time. We actually use that for carbon dating. So we figure out how old something is based on that number. All right? If you guys look at the other elements, you'll see that other elements have different ratios as well. What I want you guys to look at particularly right now is bromine. So bromine has 2 isotopes, and I want you to think about how those 2 isotopes are going to influence what we see on the mass spectra, because it is going to influence the mass having these extra neutrons. Right? So that one here, I want you guys to explain to me how you could use the mass spec to figure out that you have bromine, because you can't find bromine on the IR easily. All right, take a few moments. I'll go over the answer. Have a think. So, mass spec is very sensitive that if you have an extra neutron, it's going to affect the reading here. So what you notice when you're looking at the mass spec for bromine, first off, when we look at bromine, you see how 50%, so half of bromine has a mass of 79, and then the other half of bromine have a mass of 81. So it has 2 extra neutrons. So it's a 50-50 mix. So what happens in the mass spectra then is that you're going to get basically 2 towers next to each other that are roughly the same size. And they're going to be +2 apart. So that tells you as a marker that you have bromine. 2 peaks, two numbers away, just +2, about the same size. Okay? Chlorine is the next one, and I'll explain that one because I know we're running out of time. You see how chlorine, 75% of chlorine is chlorine 35. Then you have 25%, a quarter of it is chlorine 37. So it has, again, 2 extra neutrons. So when you look at the mass spectra, what you'll notice is, again, like bromine, you'll get 2 peaks. That's going to be 2 apart, 1, 2. The thing is that the ratio between these 2 peaks is going to be about 1/3. So this little +2 peak is the 1/3 of the size of this guy. And that's reflective of the isotope percentage. And this one you'll see actually repeating itself. So you see it here, you see it here. It's doing it twice. So both of those fragments have chlorine in it. Okay? So that's how we use mass spec to figure out those 2. All right? Questions, concerns, comments? Nope. All right, we're about halfway. Keep doing those practice-collated questions, or combination questions. Skip question 5. I have made a huge mistake in how I've designed that question, so you can't answer that one, okay? I need to fix it.